If you search the meaning of the rules, you can see many definitions like one of a set of explicit or understood regulations or principles governing conduct or procedure within a particular area of activity. According to this definition, we can define the rules for everything. There are two basic rules for health data transmission in the telecommunication structure. Rules are also needed to ensure timely, secure and without corruption data transfer between connected devices. When a problem in any of these will occur, the established balance was broken and data transfer errors will begin to appear. Here are the two rules which form the basis of data transmission. Maintaining the data integrity, delivering the data on time. Source and destination address information is entered into this data packet, and the movement of data packet in the network begins. The race against time also has begun for the data packets to reach target. The data packet must reach its destination address within a certain time. If a data packet doesn't reach its destination address on the computer network on time, there will be two reasons. Either the data packet was corrupted and the packet lost its integrity, which means data packet becomes untrustworthy, or the destination address defined in data packet is incorrect. In both cases, the data packet must be deactivated after a certain period of time. Controlling and deactivation of a data packet that has become corrupted and unusable is determined by using the time to live (TTL) and cyclic redundancy check (CRC) values. By maintaining the data integrity, the data packet is generated and addressed by source unit. This data is delivered to the target network device by using the destination address. The data has now reached its destination and is ready for final check, which is called CRC (cyclic redundancy check) before being displayed to the user. The basic operation of data packet manipulations is based on the rearrangement of these CRC values. For this reason, CRC values can also be checked during the control stages of data packets with important values. Don't forget that CRC is a type of checksum algorithm, but not a cryptographic hash. CRC is only used to implement the data integrity service where accidental changes to data are expected. The data packet sent to the target unit must not be corrupted during the transmission, and the data must not be interfered with in any way. Otherwise, corrupted data will be labeled as incorrected or false and destroyed by the related network device. Source unit create data packets, but for some reasons, these data packets may be rearranged and sent on the computer network again by using one of man-in-the-middle attack techniques. In such cases, the cybercriminal rearranged the CRC control block while editing the data packet. CRC checksum is used in detecting common transmissions errors, but not for the text changing on the data. As you see that CRC checksum is commonly used for detecting common transmission errors. CRC mismatch checks are not used to detect cyber attacks, because it's not care about changing the user data carried on it. But on the other hand, data integrity corruption could cause the security vulnerabilities and data loss. By delivering the data on time, the computer network should deliver the data packets from the source unit to the target unit as soon as possible. If the data packet reaches its destination later than it should, it loses its importance for the user. Especially in real-time video and voice communications, all data packets must be delivered to target unit without any delay. So, in which cases the data may not reach a target unit? The target unit could be disabled before data packet arrived. Wrong destination address could be used in data packet. Due to an error, the computer may generate incorrect data packets and send them to the computer network. In all these cases, the data packet cannot find its destination unit. In such cases, this type of data packet starts to circulate in the computer network indefinitely. And finally, the entire bandwidth of the network will covered and the computer network is disabled. To mitigate this possibility, packets are designed with a time to live, which is TTL. A TTL count is defined depending on the protocol used when sending data packets. Each routing device that the data packet passes on it will decrease this TTL count by 1. If at any point the TTL count is equal to 0, routing device will discard the packet. In this way, there are no idle packets left on the network. I would like to remind you of a situation that shouldn't be confused here. If you have noticed inconsistency between the sound and the video while watching a movie, sport match, or music concert over the internet, it's because the synchronization between the sound and the video cannot be achieved correctly. Because timing is very important in the transmission of data that makes up audio and video synchronizations. The source of this problem is not related to TTL values. Here the audio and the video packets have reached the target device, but the synchronization couldn't be achieved at the stage when these packets will be presented to the user. For this reason, we can easily say that one of the most important measures to be taken for cybersecurity is to be a good informatics literate, because all the processes of data usage is directly or indirectly related to each other. Devices of different brands, different applications, and different technologies can be used together in the computer network. So, how is data transferred without any problems despite so many different features? Now we can begin to work on this issue. If technologies with different characteristics act in a line with common rules and definitions, the data can only reach its destination. The figure on the screen shows the protocol, sender, receiver, medium, and the message relationships that constitutes this rule's integrity. The message is transmitted over the medium, which is set up between the sender and the receiver devices. This medium is provided using wired and wireless technologies. To ensure this transmission, the mutually agreed protocol rules must be followed. Otherwise, communication does not occur between the connected devices. Message represents the information that provides the data communication during transmission over the computer network. With these messages, the connected devices communicate with each other. These data packets are identified by the source and the destination IP addresses, source and destination MAC addresses, and the source and destination port numbers, and contains the user data. Sender produces the message and leaves it to the computer network to be forwarded to target or destination unit which wants to be communicated with. Receiver receives the message which sent to it by the source unit over the network. Main target is maintaining data integrity and delivering the data on time between sender and the receiver. Media defines all the wired and wireless communication paths used for the transmission modes of data between the sender and the receiver on the network. Fiber optic cables, copper cables, coaxial cables, Wi-Fi, WiMAX, LTE, radio links are the different forms of the medium. Protocol is a set of rules that define to ensure the data communication. With these rules, connected devices start to talk the same language and to communicate with each other. Protocol rules must be followed by connected devices. Otherwise, even if the devices are physically connected to each other, data communication cannot occur. When the physical connection is established, mutual interaction can begin between the sender and the receiver via electrical or electromagnetic signals. In order for this interaction to turn into data communication, which is meaningful data, electrical signals must be arranged in accordance with protocols. In this way, the data is recreated by the destination unit in accordance with the original form, which created by the source unit. This is where the CRC comes into play. CRC is a function that detects structural changes in digital telecommunications network. In this way, it is determined that the user data in the source and the destination units are the same. But keep in mind that cybercriminals can rearrange the CRC data to prevent the changes being noticed. As we mentioned on the previous slides, the data delivered from source to destination in a timely manner and without deviations by using protocols. Protocols define the standards required for network devices, which are manufactured by different vendors with different technologies and for different purpose of usage. The purpose of the protocols which created in accordance with the standards is to ensure that the action always yields the same result if repeated under the same conditions. By any of the standard is created, rules and sequences of operations are provided for all source and destination devices. This standard ensures that the request action under the same condition is always performed the correct response by the destination. These standards may be classified into 4 general groups: international standards, national standards, industrial standards, professional standards. Various control, inspection, and approval mechanisms and much more time are needed to develop these standards. These standards are grouped into 2 sections: de facto standards and de jure standards. De facto standards have not been approved by any national or international organizations, so the de facto standards are not official. The generally accepted standards for the reasons such as user demands and the guidance of the companies active in the market are called de facto standards. Today, the QWERTY keyboard used on the keyboards of the mobile devices, the HTML used when creating web pages, and the Microsoft Office, Word, Excel, etc. applications are examples of the de facto standards. In other words, it was developed by the companies or people and is preferred by many users. De jure standards, the standards in this group are approved by the official committees, legal standard boards, or national and international organizations. The OCI, which is Open Systems Interconnection 7-layer reference model, approved by the Internet Engineering Task Force organization, and the ISO, which is International Standards Organization, is an example of the de jure standard. With the introduction of the de facto and de jure standards, many of the previously developed manufacturer-specific standards have been revised to create a common standard. Then, technological developments in computer networking are started to be planned in line with these protocols and suitable for common use. Today, all kinds of technologies are developed in accordance with these standards. Protocols and standards are periodically reviewed for this protection of validity and maintaining up to date. In this way, necessary changes can be made in accordance with the developed technologies and researches.